All right, today we're looking at 2D arrays. You folks went over the information last night. I'm just going to review it. If you have a question, make sure you let me know at this time. A quick recollection of one-dimensional arrays. You can immediately create a one-dimensional array using what's called an initializer list. When you do that, you state the type here. Then you put square brackets to indicate it's an array. Then you name your array. And then inside of curly braces, you put any elements you want after the equal sign. And since it's a list, you use commas to separate any elements. So this is like when you know exactly what's going to go into the array at the time of creation. Notice for a one-dimensional array, there's only one set of square brackets. Now, I know we just went over array lists. You have to change gears, which can be a little bit tricky because you think array lists and arrays behave kind of similar, but they access information, they change information very different ways, and they get instantiated in very different ways. So your brain has to go back to one-dimensional arrays, and that's why I've included the information here. Keep in mind, if you don't know what elements are going to go inside of an array, you can just state the size of it at the beginning. And if you do that, it follows this format. Type square brackets, then the name of the array, followed by equals new, and then the type again, and then however many elements you are going to put into it eventually. Now keep in mind, when you do something like this, the array automatically gets initialized. Let's do a quick review. For integers, what does every element automatically get initialized to? 0. For doubles, what does every element get initialized to? 0.0. For booleans, which we're going to be using today, what do they automatically get initialized to? False. And let's see, for strings and any other objects, they get initialized to what? Null. That last one is important because with an array of zeros, you can do stuff. With an array of 0.0s, you can do stuff. With an array of falses, you can do stuff. You cannot do much with an array of nulls. You can't do something like find the length of something that's null. You can't do a substring on a string that's null. You can't do any of that stuff. You can't uppercase it or use index of on an element that's null. So just be very, very careful when you're dealing with an array of objects like strings. It initializes it to null, so you'll probably want to write a for loop to go through that array and then initialize every element to something called a constructor and create elements there. To access individual elements, since it's a 1D array, in a 1D array we would just use a single subscript with the index numbers. Keep in mind, index or indices, I just spelled it all wrong, indices start at 0. And they go to the length minus 1. So for example, you have an array of 100 elements, the indices go 0 to 99. You have an array of 1,000,000 elements, 0 to 999,999, etc. Keep that in mind. The first element is at index 0. All right, now, with that behind us, we are masters of the one-dimensional array. What the heck is going on with two-dimensional arrays? Well, it kind of just looks like a grid. And we talked yesterday, there's a lot of games. You're probably familiar with two-dimensional arrays from playing chess, checkers, Minesweeper, Tetris, etc., etc. Civilization. Most tower defense games. Clash Royale, probably a two-dimensional array, I would assume. Okay. So, I've never played it, so don't ask me. This is an array. We would say that this array is a 3x2 array. We always do the rows first and then the number of columns. So this is a 3x2 two-dimensional array. To create this array, to declare it, just like a one-dimensional array, I would do the type first. But since it's two-dimensional instead of one-dimensional, I have to do two sets of square brackets here for a two-dimensional array. You want to guess how many sets of square brackets you'd have for a three-dimensional array? Oh my gosh, you're right. It is 3. Okay. Then, just like a 1D array, you state the name of it. Then you say new, followed by the type. And then lastly, we always do the number of rows first. Rows go left to right. And then we do the number of columns second. And this is the type of declaration instantiation we would use if we know how big it's going to be, but we're not automatically initializing the elements here. So this is how we would create a 2D array. Now, why do I have a picture of RC Cola over there? This is not a sponsored, it's not a sponsor. I just want to make that clear. My YouTube career has not eclipsed my teaching career yet. I'm not sponsored by RC Cola. What if I just pulled up my shirt, it was RC Cola? It's not. I'm just drinking an RC Cola. I got an RC Cola hat on. Let's be honest, RC Cola doesn't have, never mind. They can't afford me is what I'm trying to say. Whoa, 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 if RC Cola sees this video, don't at me. Okay. So, why do I have RC Cola? Because we always do rows first, columns second. Just think of RC Cola, rows, columns. This is called row major format. We always do the row number first and the column number second. Why is that important? The College Board, any questions about 2D arrays will refer to a two-dimensional array in row major format, where they refer to the row number first, followed by the column number. Whether that means you're declaring and declaring and instantiating an array to be a certain size, or you're just trying to get a certain element from that array, you always do row number first, column number second, and keeping in mind that when you're talking about positions, they start at 0. So, there's a couple different ways I can make this two-dimensional array up above. If I want to declare it, instantiate it, and then initialize it, sorry, I missed a step here, instantiate and then initialize, I would do something like the following. I would say it's a two-dimensional array that has 3 rows and 2 columns, and then I would go through and initialize every element. Notice when I initialize an element, I always do the row number first, followed by the column number second. So this is how I can go ahead and initialize it. They all start at 0, and then I go ahead and I change every element to something like that. You learned yesterday in your reading that you can use something called an initializer list. In an initializer list, we do one set of curly braces on the outside. This indicates that we are going to have multiple arrays. Did anybody see yesterday that they referred to a 2D array as an array of arrays? That's what this is showing you. The outside braces say this is an array, and then the inside braces say what the elements are in the array. In this case, it's an array of 1D integer arrays. So in this case, every single one of these blue braces that I'm coloring in here represents a row. So this would actually be the 0th row, this would be the 1th row, and this would be the 2th row of my 2D array. Sorry, I can zoom in a little bit. I think I can. There we go. And so you can use what's called an initializer list if you know exactly what's going to go inside of the 2D array when you create it. Notice I do row by row. Now, do you have to format it like this? No. I could do that all on one line. Frankly, I ran out of room, so that's why you see it on separate lines there, but I could have just, after the comma, done 24, 25, and then after the comma, done 26, 27, all on the same line. One last thing to notice, just like a one-dimensional array, there are commas separating each one of the 1D arrays. So basically a 2D array is an array of arrays, which is important to understand here. When you use the first subscript, you're saying which array to go to. When you use the second subscript, you're saying which element in that array you want to go to. So I'm just going to write down something that says 2D arrays are arrays of arrays. 2D arrays are arrays of arrays, and basically, yeah, that's good. The first index, when you're subscripting them, like over here, this would say go to the 0th row, or go to the 0th array inside of A and give me the 0th element from that row, so to speak. So when I say A sub 0, the first thing that happens is I go to row 0, that's A sub 0, and then I do sub 0 of that row, which would give me 22. Does that kind of make sense? Okay. The last one, I'm not really going to get into it that much, but if you wanted to send an anonymous object array to a method for whatever reason, you could do what's on the right side of the equal sign all by itself, and this is how you create an anonymous 2D array in this case. Now, I know I'm talking about anonymous, and I went and named it A. If you just do the right side of the equal sign, this would create an anonymous 2D array. And I don't know, maybe you send it off to a method, or heck, you could put a 2D array inside of a 2D array if you wanted to. What would that be? I don't even want to talk about it. I don't know. Squared. We've reached the 4th dimension and I've gone cross-eyed. Okay. So something like this. Questions so far? A lot of information, hopefully rehashing and invigorating and re-energizing what you learned about yesterday. Questions? All right, on to the back. Oh, good. This formatted nicely. Okay. Something that's really, really important for when we're going to start writing loops with 2D arrays, which we should be able to look at tomorrow. You need to know how long a 2-dimensional array is. When I say how long, think of a 2-dimensional array. It actually has 2 dimensions that you have to worry about, kind of like the length and the width, or if you want to call it the base and the height or whatever. So how do you figure those things out? Well, if you want the number of rows, you want to do something like the name of the array dot length. That will give you the number of rows. So if my array is named A dot length will give me the number of rows in the array. If I want to figure out the number of elements, or essentially the number of columns in a row, then I can go ahead and do something like A sub 0. What does A sub 0 represent? Just by itself, what does A sub 0 represent? Remember that A is an array of arrays. So what does A sub 0 by itself represent? The first row. So when I do A sub 0 dot length, it's giving me the length of a row, which in other words tells me the number of elements in that row. Or if you want to think of it as the number of columns, you can think of it that way. So when I do A sub 0 dot length, this whole thing here, this gives me the number of columns in a row. So if you want to figure out the number of rows, you just do the name of the array dot length. You want to figure out the number of columns, you do a row dot length, especially if it's rectangular, which means that it's a perfect rectangle. Every row is the same length. If every row is the same length, A sub 0 dot length will tell you how many columns there are in the array. If it's not all rows the same length, it'll just tell you the number of elements in the first row. A quick note about this: if it is rectangular, meaning all rows are the same length, how can I figure out the number of elements? Let's say all the rows are the same length. How can I figure out the number of elements in the array? Yeah, go ahead, Eli.
Length of the A sub 0 times how many rows there are.
Yeah, so if I do A sub 0 dot length, that's the number of elements in a row, times, yeah, it's something like this. This will give me the number of columns times the number of rows, which is the number of elements. If it's a rectangular array, meaning all rows are the same length. Number, elements. Oh, but only if it's rectangular. There are some cases where you might have 2D arrays where not every single row is the same length. So now that we're looking at this and we can figure out the number of rows and number of columns, just foreshadowing a little bit, we've written for loops to process 1D arrays. How do you think we're going to use for loops to process a 2D array? A nested for loop situation. Usually we count up to a dot length or the array dot length in one of the loops. We're going to have two loops going on when we start looking at nested for loops for 2D arrays. One that loops over the row number, one that loops over the column number. So we'll look at that a little bit more tomorrow. It's not necessary knowledge for today. It is possible to have a ragged array, which you looked at a little bit yesterday. This just means that not every single row has the same number of elements. I'm not going to talk about this segment too much because it's not supposed to be on the AP test. But if you do have rows that are different lengths, there's some information here. Maybe you want to use it in a personal project. Again, I'm not going to talk about it too much because it's not supposed to be on the AP test. So I just included it for completeness. The last thing, which we already talked about, and you know, it says, as with all one-dimensional numeric arrays, all elements of two-dimensional arrays are also automatically initialized to 0 until specific values are given. I think we said on the other side, Booleans are automatically initialized to false. Strings and any other objects are initialized to null. And that's really all I have to say so far for the first day of 2D arrays. Are there any questions? Yes, Daniel. So why is a dot length the number of rows? Okay, so that's a great question. When you look at, it might be more clear if we look at this number 2 initializer list thing. Do you see those green commas I have there? They're kind of tiny. So those green commas are separating the elements of A. What are the elements of A? The elements of A are arrays themselves. So basically when I say a dot length, I'm saying how many arrays are in here. When I ask how many arrays there are, we're thinking of it as how many rows are there. Does that kind of make sense? Okay. And when I say a sub 0 dot length, it says go ahead and get the first row and figure out the length of that row. So that should tell me the number of elements in that row. Does that make sense too? Okay. Yesterday, we talked about Conway's Game of Life. I went and I programmed up a relatively decently, I'm not going to say it's perfect, but a relatively decently working one yesterday while you folks were going through and taking your notes here. I'm going to show it to you really quickly, and then over the next 2 days, I'm going to explain how we're going to actually code it ourselves. I don't want to give away too much of the code that you're going to write here, but I do want to kind of show you the functionality of it. I don't care if there's a new version. Okay. So, Conway's Game of Life, what I've done is I've made it so that it's going to be a 50 by 50 grid. If you remember from yesterday, there's some special patterns like a glider, and I've made it so the person can type in everything, and then when they hit enter, it starts going. I think I have it going at a couple frames a second here, but this is how a glider works. I also made it, I believe, so if you hit control, it'll set it back to clearing mode, and then you can do stuff like, I believe another pattern, wasn't it 10 across? I think something like that makes an interesting pattern as well. So what we're going to do, oh wait, there's one more cool one. Hold on. It looks like this, I think. Nope, not you. Oh yeah, I made it also so if you click on one of them, it erases what it is. Is it this one? No, okay. Clearly not cool, okay. When has anything I've ever done in this class been cool? Let me try this again here. Hold on. I'm just joking when I say that. We do cool stuff every single day. I think that's a pattern. Check that out. Have you ever seen like one of those Rorschach tests where they have like the ink blots, and it reminds me of one of those Rorschach tests. Like, what do you see? Okay. So we're going to program Conway's Game of Life over the next couple days. I've broke it down into several specific methods, 5 specific methods that you need to make Conway's Game of Life in processing. The first 3 we are going to do today, and you can do them without without processing the array using for loops. So what I'd like you to do is go to the Google Classroom, and you should see a paste bin that says Java Conway's Game of Life. Now, I know for a fact for some of you it's been very long since you've used processing, but I've tried to make it so that this is as close to regular Java as possible. I'm going to go ahead and highlight and copy the code. It's, I don't know how many lines, 71 lines. I'm going to copy it. At this point, since people have dragged and dropped processing all over the place and made a disaster of where it's located on the computers, I think the best way to find processing on your computer is just by hitting the Windows key and just start typing processing, and then usually it pops up. Again, I did have it all in one folder at some point, but some very clever students were like, I'm just going to drag it out of this folder. And then for whatever reason, it moved it for everybody else, so now nobody knows where it is on their computer. How clever. So again, I'm going to hit the Windows key and type processing, and it should pop up there. I think I can just, it should be this one with the logo, that's I to the third. Are people finding that? Yes?
Does the, if you pin it to your taskbar, you can like pin processing of JGraphs to your taskbar. You don't search anything ever.
Oh, nice. Cooper, yeah? So when you hit the Windows key and you type processing, nothing happens? What about, let's see, how much of the dick is the first name? Total dingus behavior. There's not even a top site folder anymore. I'll come over and fix it for the break. Just give me a second. Anybody else having processing issues? All right, I'll come over and fix it during our 2-minute break, okay? All right. What I'd like you, but just give me 1 minute and then I'll go ahead and do that. You can go ahead and paste in that code to processing. I'm just going to explain the code really quick, and then we'll take our and what you're going to do, and then we'll take our 2-minute break, okay? So what I did is, don't worry too much, but up at the top I've created a couple different colors that we'll use, so it looks like the Conway's Game of Life that that you guys looked at the other day. So I made a yellow and a gray. I don't think we're going to use that today too much. And then I made some instance variables, and these are important for what you're doing today. Grid, essentially what we're going to do is model Conway's Game of Life with a grid of Booleans. Guess what? When the two-dimensional array element is false, that element in the grid is unoccupied. When the element is true, that element in the two-dimensional array is occupied. So false is unoccupied, true is occupied. I've done the setting up, making a window 500 by 500. I've made the background gray, and you'll see that there's two methods that are called initGrid and drawLines. Right now, I believe you should be able to click play, but then if you click anywhere on the screen, it's going to give you like a null pointer exception, so I just wouldn't do it. Frankly, if you click on the screen and it airs out, I would just click back over here and ignore it for the time being. I've taken care of all of setup for you. I've taken care of all of the draw method for you. Notice inside of draw, I've got a couple things going on. If you click the mouse button, it'll change an element and slow things down just for the time being. And then I've also got it so if you click enter, things will kind of slow down to actually run it. And then I've got, if you click control, it'll kind of clear out the screen. So you don't need to worry about that right now. You're not going to do anything in setup and draw for today. And my change element method, there's some magic going on there. You don't need to worry about it. What you are going to worry about is there's a big comment that says day 1 down at the bottom. For the 3 different methods you're going to write today, there are specific steps and method headers and given to you. You're going to write a method called initGrid, where you're going to make a Boolean grid, initialize that Boolean grid to be 50 by 50, initialize the box width and box height to be the number of width and height divided by the number of boxes. There are going to be 50 boxes in each row. Remember, you can use width and height to do that. For draw lines, if you looked at my original example, you saw lines. Now, this one's a little bit tricky. You are going to have to use 2 different sets of for loops to draw a set of horizontal lines and then a set of vertical lines that makes a 50 by 50 grid. You'll have to think about that a little bit. For those of you that are already thinking about it and maybe wondering what to do, remember how a window works. What's the coordinates of the top left corner? 0, 0. And then the bottom right-hand corner would be the width divided by the height. And what your goal is to make two different for loops. One of the for loops is going to draw your lines going across 50 times. You'll write another for loop to draw lines going down 50 times to make a 50 by 50 grid. The last one that's super duper important for this game of life is the count neighbors method. Remember from yesterday when you were playing Conway's Game of Life? Essentially it thinks of every element almost like a tic-tac-toe board. If we're talking about the element right here, we need to determine how many neighbors it has. And I've tried to break it down for you so that you figure out how many neighbors are up here, basically which one of these elements is true, how many of these elements are true, and then how many of the elements in the row below are true. I've got comments in here telling you what to do. Essentially, you're taking the grid and you're determining which elements are true or false. Now, one thing you have to think about, what if I'm in the top left corner? Let's say this is my grid and I want to find the number of neighbors for this guy. Can I check the row above him? No, there's no row above. Can I check the column to the left? No, there's no column to the left. So I have to be very careful that I follow the bounds issues of my array as well. I'm going to be walking around helping. You're more than welcome to ask for assistance from your neighbor as well. I suggest you do when you walk your way through this. Let me know when you think you're finished. We're going to take our 2-minute break right now as well, so if you want to get a drink of water, use the restroom or anything like that, go ahead and do so. And I'm going to walk around and help for the rest of the time here.